In 1859, a massive solar flare hit Earth so hard, it set telegraph wires on fire. That storm was called the Carrington Event, and it was the most powerful solar storm ever recorded. Back then, all we had were telegram lines. Today, we have satellites, GPS, power grids, internet, all vulnerable. If a Carrington-level solar storm hit us now, experts say it could cause trillions in damage, blackouts across continents, and knock out communication worldwide. So, what are solar storms? How do they happen? And are we due for a Carrington 2.0? Let's break it down and find out if the sun is more dangerous than we thought. Chapter 1. What are solar storms and how do they work? Let's start with the basics. What exactly is a solar storm? Imagine the sun as a colossal boiling sphere of plasma, constantly churning with magnetic energy. Occasionally, this energy becomes unstable, leading to sudden releases known as solar flares. These flares emit intense bursts of radiation across the electromagnetic spectrum. But the real game changer is the coronal mass ejection, CME. Think of it as the sun hurling a massive cloud of magnetized plasma into space at speeds up to 2 million miles per hour. If Earth lies in the path of this CME, the consequences can be significant. When a CME reaches Earth, it interacts with our planet's magnetosphere, the protective magnetic field shielding us from cosmic radiation. This interaction can cause geomagnetic storms, leading to disturbances in Earth's magnetic field. So, what happens during a geomagnetic storm? Auroras intensify and expand. The most visually stunning effect is the enhancement and expansion of auroras. These natural light displays, typically confined to polar regions, can become visible at much lower latitudes during strong geomagnetic storms. For instance, during the Carrington Event of 1859, auroras were seen as far south as Cuba and Colombia. Disruption of communication systems. Geomagnetic storms can interfere with radio communications, especially those relying on high-frequency bands. This disruption can affect aviation, maritime operations, and military activities. Satellite malfunctions. Satellites orbiting Earth can experience increased drag due to the expansion of the Earth's atmosphere caused by the storm's energy. Additionally, the storm can induce electrical currents in satellites, potentially damaging onboard electronics. Power grid failures. One of the most concerning effects is the induction of electric currents in power lines, which can overload transformers and lead to widespread power outages. A notable example is the 1989 geomagnetic storm that caused a 9-hour blackout in Quebec, Canada. Why should we care? In our modern, technology-dependent society, the implications of a significant solar storm are profound. From GPS navigation and communication systems to power grids and satellite operations, many aspects of daily life are vulnerable to the effects of geomagnetic storms. Understanding solar storms is not just about scientific curiosity, it's about preparing for and mitigating potential disruptions to our technological infrastructure. As we delve deeper into this topic, we'll explore historical events like the Carrington Event and discuss the potential risks of future solar storms. Chapter 2. When the Sun Hit Earth. Now that we understand what solar storms are, let's talk about the biggest one in recorded history. The Carrington Event of 1859. This wasn't just any solar flare, it was the largest and most intense geomagnetic storm ever observed, and it all started on September 1st, 1859, when two British astronomers, Richard Carrington and Richard Hodgson, independently observed a massive burst of white light on the surface of the Sun. It was a solar flare, but at the time, they had no idea what kind of chaos it was about to unleash on Earth. Just 17 hours later, which is incredibly fast for solar particles to reach Earth, a coronal mass ejection slammed into our planet's magnetic field, and then things got weird. Telegraph systems around the world started to fail. In some places, the telegraph wires sparked, caught fire, and even shocked operators. There were reports of telegraph machines working without being plugged in, simply powered by the energy in the air. Auroras exploded across the skies, not just in the far north, but all the way down to the Caribbean, Cuba, Hawaii, and even parts of South America. Newspapers said people could read print at night by the glow of the aurora alone. And remember, this was 1859. No satellites, no internet, no global power grid. If a storm that powerful happened today, it would be an entirely different story. According to a detailed article from space.com, the Carrington Event likely released the equivalent energy of 10 billion atomic bombs. It was the perfect storm, a massive flare, a powerful CME, and a direct hit on Earth's magnetic field. We now know that events like these aren't impossible. They're rare, but not unique. In fact, similar but smaller solar storms have occurred since then. In 1921, a geomagnetic storm caused widespread damage to telegraph and telephone systems. In 1989, a CME caused a 9-hour power outage in Quebec, Canada, knocking out electricity to millions of people. And in July 2012, a Carrington-level CME narrowly missed Earth by just 9 days. If it had hit, scientists estimate it could have caused $1 to $2 trillion in damage globally and taken years to recover from. So here's the scary truth. A modern-day Carrington event isn't science fiction. It's just a matter of time. And in Part 3, we'll explore exactly what would happen if one hit us today. From fried satellites to collapsing power grids, and how unprepared we might actually be. By the way, if you haven't seen our other video on the Parker Solar Probe, go check it out after this one. We talk about how NASA is literally flying a spacecraft through the Sun's atmosphere, and how it's helping us predict and prepare for solar storms like the one we're talking about now. It's all about early warning systems and how we might protect Earth from the Sun's fury. And hey, if you appreciate the research and effort we put into these videos, please subscribe. It really motivates us to keep creating more content like this. All right, let's get back to the topic. Chapter 3. What if it happened today? So, what would happen if another Carrington-level solar storm hit us today? Let's not sugarcoat it. It would be catastrophic. Back in 1859, all we had were telegraphs. But today, we're completely dependent on satellites, power grids, GPS, internet, banking systems, and wireless communication. And all of it could be affected by a massive geomagnetic storm. Here's how it could unfold. A strong coronal mass ejection, CME, would hit Earth's magnetic field and start wreaking havoc in orbit. Satellites would experience increased drag, forcing them out of position. Worse, the energetic particles could fry onboard electronics, shut down communication systems, and even cause satellites to go completely offline. That means no GPS, no satellite internet, no weather tracking, and no satellite-based emergency communications. Even the International Space Station could be at risk. The biggest threat? Right here on Earth. The storm would induce massive electrical currents in our power lines and transformers. These geomagnetically induced currents, GICs, could overload entire sections of the grid. According to a 2013 study by Lloyd's and the US government, a Carrington-type event today could leave 40 million people in the US without power for weeks or even months. And we're not just talking lights out. No power means no refrigeration, no water pumps, no gas stations, no banking systems, and limited emergency services. Hospitals would run on backup generators for as long as the fuel lasts. Estimates say a modern solar storm on Carrington's scale could cost between $1.5 to $2.6 trillion globally in the first year alone. Recovery? That could take a decade or more, depending on how widespread the impact is. In July 2012, NASA satellites observed a massive CME, nearly identical in power to the Carrington Event, that missed Earth by just 9 days. If Earth had been in the wrong spot in its orbit, we'd be living in a very different world right now. NASA and space agencies do monitor the Sun 24/7 using satellites like SOHO, SDO, and Parker Solar Probe. We get alerts and forecasts, kind of like space weather reports, but there's still no real defense. The best we can do is prepare, protect satellites, shield power grids, and take this threat seriously, because it's not if another Carrington event hits us, it's when.